Welcome to week 2. It is a short week, so I'm going to do a quick lecture on sex-linked traits, and then the only thing you're going to have to turn in is the 3 phrases that you selected by giving me numbers 1 through 30. And if you didn't select, some were given to you fairly randomly, but when I'm choosing, I'm not going to give you the real short ones. So what you need to turn in is those phrases by Wednesday, and then you get to enjoy Easter break, and we'll finish up this genetic stuff in week 3. But part of that will be these sex-linked traits, so I'm going to go through fairly quickly with this, but hopefully you'll understand what's going on. So a sex-linked trait is just one where the alleles occur on the X chromosome. And we'll go through and we'll show you exactly what that looks like. And the trait is more prevalent in males, and hopefully by the time we're finished you'll understand that there's a good reason for that. So just to begin with, in determining the sex of an offspring, 2 X chromosomes are female and X and Y is male. And if we just cross this, and the only way you can cross, no matter what culture says now, this is the only way that we're actually going to get to make a Punnett square. So if we put mom here, she can either give an X or she can give an X. And dad can give an X or dad can give a Y. Now when we put these together, these 2 will be XX, same thing here. And then here we get XY and XY. So you see the chances are 50-50 for either a daughter or a son. That's just the normal math, how it works with the Punnett squares with the 2 sex chromosomes that are the 23rd pair. Now if we have a allele that's linked to one of these, we write it as a superscript to that. For example, in color blindness, normal vision is dominant. And I often see where and it kind of makes sense because we're talking about color blindness, they use a C, but and a capital C would be for normal and a lowercase c is for colorblind, but it's really hard to tell the difference between C and C. And they look very similar. So I'm going to use capital N is the normal vision because that is dominant, and a lowercase n will be colorblind. All right, so let's just do some crosses and you'll see how it works. If we cross these parents, first of all, what kind of parents are they as far as vision? You can see here that it's only got a dominant, so this one's going to be normal, and this one has a dominant. So in this case, they're both going to be normal vision. Normal vision dad, normal vision mom. Now, mom is a carrier. She has an allele for color blindness, but she sees exactly the same as if these were both capital N's. It's not that this in any way influences the normal vision. So let's see what we would have. Mom, if we keep consistent, put mom up here, can give us a normal X or can give us the colorblind allele. Dad can give us the normal X or can give a Y. So we would get X, and we could get X, we could get X, we get X. All right, now both of the daughters are going to be normal vision, although this one would be a carrier, because it has the allele for color blindness, but it's covered up by the dominant normal vision. Then we have a normal vision son, and we have a colorblind son. This son has color blindness, and you can see it's much more likely for a son to be colorblind because here got the same colorblind allele. They both got this allele is here and it's there, but the daughter gets hers covered up by dad's normal vision. Here, there is no second chance to get a dominant one because dad just gave a Y, which does nothing for vision, and so the son becomes colorblind. Now this actually is the case in my family. I have two normal vision parents, and my older brother and I, normal vision. My two younger brothers are colorblind. So for them to be colorblind, mom had to be a carrier. Now we've never gone back to trace it back to see how far that would have gone. There's not many generations, nobody is alive anymore to ask, and they didn't really seem to take note of that. But we would get a colorblind son. Now in this case, here we have that son, let's say, grew up and married a normal vision wife. So we've got colorblind dad, normal vision mom. So we're going to get a normal vision daughter, a normal vision daughter, but they're both carriers, and then we get a normal vision son, and we get a normal vision son. All right, now that Y isn't supposed to have that on there, but sons, men can't be carriers. They can't be normal vision but carry the allele. If they have the allele for colorblindness, they are colorblind. But women can carry the colorblind allele but have it masked by the dominant. Now if we have a colorblind dad and a normal vision mom, but she is a carrier, then we get and then we get a normal vision daughter, and we get a normal vision son, and then we get a colorblind daughter and a colorblind son. So here is a case where we get a colorblind daughter. It's very rare, but that's one of the occasions. Now, and it doesn't mean that if you have a daughter or if you have two daughters, they're both going to, you could have four daughters and they would all be normal vision. It's just you could have three daughters and they could all be colorblind. So this is over a large enough population. If parents were able to, if they were like, I don't know, insects or something, and they could have 1,000 offspring, then it would work out to these proportions. Half of the females would be colorblind and half of the males would be colorblind. But in the size of our families, it's just very random how it can be. But this is a case where you can have a colorblind daughter. Now if we have everybody is colorblind, then you can see that all of the offspring there isn't any way to get a normal vision in there. So if you have a colorblind woman who marries a colorblind man, all of their children will be colorblind. Now, I don't know if that would be enough to say that, no, I can't marry you because I can't do that to our kids. My brothers have lived very happy and productive lives being colorblind. But that would be a case where everybody would be colorblind. So from what we went through, what must be true if there's going to be a colorblind daughter? What must be the case if there's going to be a colorblind daughter? So you can tell if you've got a shot at that. And dad must be colorblind. If mom has normal vision and dad has normal vision, even if mom's a carrier, you're going to have, all your daughters will have normal vision. If dad is colorblind and mom has normal vision, then you can get colorblind of both if mom's a carrier. If mom is a normal visioned and she's not a carrier, both of them are. If she's homozygous for the normal allele, all of your daughters will have normal vision. But if dad sees colors, then none of the girl offspring will be colorblind. All right, if you want to check colorblind tests, if you want to see what that's talking about, you can, and how they test. If you go to enchroma.com, and it just goes to their homepage, and they'll try and sell you some really cool glasses. And they have, you can put on glasses and it kind of helps, it corrects some color blindness a little bit, not completely, but it does give you some color with that. And then there's a tab, colorblind test, and I can show you that. Here's their website, and right up here is the colorblind test. And if you go to the colorblind test, it's going to come here, and this is where you'd start the test. But this is what it looks like. It'll give you, I don't know how many, there's probably about 15 questions, and it'll just show you a circle with different colored little circles in it, and you will identify what number is there, or say if you can't see a number, or it looks like there might be one but you can't tell, you're not really sure, and you just click through at the end, and then it'll give you the results. It will try and get you to put in an email so that they can mark it to you. And if you want to get some marketing, you can go ahead and do that. Otherwise, you can just click down below and say, no, skip to the results, and it'll just give you the results. You don't have to put in your email address to get marketing. Your parents would probably appreciate that if you're on using don't put in one of their email addresses, because they don't want any more junk mail. So that's a way you can take the colorblind test. It's a very quick, simple test. And so next week, it's just the 3 phrases, and send them back. I will send those to you in a pan, so you can just look at those and just make sure that when you type them out, after you figure them out with the same thing that you use for the practice this week, or last week, I guess it is, once you're watching this video, use the same codes to go through. Make sure you put the numbers down beside it. Just type it out with the number and then drop it in the Dropbox. All right, and the it's Friday, but Sunday's coming video will be on the YouTube page, so that you can enjoy that for Easter. So hope you have a good Easter. And this week there won't be a Zoom because that's on Thursday. We don't have school on Thursday, so enjoy your break from being in school, although you're enjoying that already. Hopefully you're enjoying it. We'll talk to you next week.